Welcome back, folks. In this video, we'll talk about a review of trigonometry. And for this, you can see the back of your formula sheet. You'll find some formula that we'll talk about, namely the Pythagorean theorem and the trig ratios. Okay, first thing to check is to make sure that your calculator is in degree mode. Degrees, radians, and gradients are all ways to talk about angles. In physics, we usually use the degrees method of talking about angles. Okay, first of all, quick review of Pythagorean theorem in a right triangle. We have A, B, and C is what we generally label our sides of our triangle as. Sides A and B we talk about as the legs, and side C we talk about as the hypotenuse. Okay, and then Pythagorean theorem is taking the sum of the squares of the two legs, so A squared plus B squared, and that will be equal to the square of the hypotenuse side. Okay. When it comes to our trigonometry ratios in a right triangle, the first thing that we're going to need to do is we're going to need to label an angle, and the symbol that we'll use for that is theta. Okay, so the reason that we want to label theta is because once we label theta, then we can go and list what our opposite, what our adjacent, and what our hypotenuse sides are. The hypotenuse is, of course, always across from the 90-degree angle. The opposite side is always opposite of theta, so that's why we always want to label theta first. Then we'll label our sides, OA and H. Okay, next thing we'll do when using these things to solve problems is we'll state our three ratios. State one of our three ratios, and then we'll plug and chug. So our three ratios are sine of angle theta is just a comparison of the sides of the opposite side divided by the hypotenuse side. Okay. When we talk about the cosine of theta, that is a ratio between the adjacent side and the hypotenuse. Okay, and then tangent of theta is your opposite side over adjacent. Okay. Okay, so we've seen these before, and then we like to remember the acronym SOHCAHTOA. Okay, and that just references the first letters of our ratios and then which sides they correspond to. Okay, SOHCAHTOA. Okay, so let's go put that into action and see what that looks like. Okay, so we'll look at a couple of examples where we are going to solve each triangle. And what that means is to find all sides and angles. Okay, so in this first example, let's look for finding our hypotenuse side. Okay, and for finding that, we can say that c squared is equal to a squared plus b squared, and those are our side lengths. Okay, so we'll go and plug and chug some numbers for those, and we'll find that c squared is equal to 225. Okay, and if we take the square root of both sides, we'll find that our side length c is 15. Okay. Okay, now if you want to go and now find the angles in here, I'm going to label, these are the four steps that I drew out just above here. These four steps are, or these three steps, and we're going to add a fourth. We will label an angle. Okay, we'll label our sides. We'll write down what ratio we're talking about, and then this P and C is to plug in some numbers and chug out an answer using our calculator. Okay, so we've labeled our angle theta. Now we know that our side over here, we'll call that opposite. This is our adjacent, and this is our hypotenuse. Okay, so now if we use the ratio of sides of 9/12, that's going to be the tangent, and then 9/12. So the tangent of theta is 9/12. So the tangent of our angle is 0.75. And now we have to go and use that inverse tan button. Okay, and what that does is it kind of undoes the tangent ratio. So it's the opposite operation to tangent. Okay, so if you take the inverse tan, you'll end up finding what that angle is going to be. Okay, and if we go and find the inverse tan of 0.75, you end up with 37. If we just round that, it's going to be 37 degrees. Okay, and our last angle, our angle up in the top here, this would be our angle in blue. Let's call that beta. Okay, our angle beta. We can do that by just knowing that angles in a triangle add up to 180. So if we do 180 minus the 90-degree angle that's there, minus the 37 degrees that we just found, we should get an angle of 53 degrees for that other angle. Okay. Okay, next example. If we have a triangle where we have a side and an angle, well, let's reference that angle. That's kind of step one. Let's identify our angle before we go and label this the opposite, adjacent, and hypotenuse sides. Okay, and then if I want to find what our hypotenuse side is, we can set up ratio of two sides for sine. So we can put the opposite side over hypotenuse. So our opposite side is 12.5 over our hypotenuse. Okay, and then to solve for what that side is going to be, the hypotenuse would be 12.5 over the sine of 38. Okay, so that hypotenuse side should have a length of 20.3. Okay, in a similar fashion, we can look at the comparison between our opposite side over the adjacent side, and that's so that we can go and find our adjacent side. So that's going to be equal to the tangent of 38 degrees. Okay, looking at opposite over adjacent. Okay, and I'm going to skip to this and just show an answer for this. If you plug and chug that, you should get an answer of 16 for the side length of this adjacent side. Okay. Okay, lastly, there's an angle in here. And this angle, if we look at 180 minus 90 minus 38, okay, that angle is going to be 52 degrees. Okay. Now, if we put it into an application, trigonometry as it comes to an application, let's say we want to find the height of a building. So if we want to draw a big building here, okay, and this would be the height of our pen high. This is a pretty common way that surveyors will find out the height of things. Okay, if we, with our eyeball, first of all, we know that we are 24.5 meters away from the building. Okay, if you've measured an angle of inclination when you're looking up to the top, if you've measured an angle of inclination, 36 degrees. Within this top triangle, okay, we'll have a side of 24.5 meters. We'll have the angle of 36, and that's going to allow us to go and find the height from your eyeball to the top of pen high. Okay, so I'm just going to redraw that to make it a little less of a scribble here. So if we have 36 degrees, 24.5, we've got a right angle. Okay, and I'm going to just label this as our opposite side. Okay, and now if we set up a ratio of our opposite over 24.5, which is our adjacent side, that is equal to the tangent ratio, tangent of 36. Okay, so if we go and plug and chug now, we can multiply both sides by 24.5. Okay, and we can find that the side of that triangle would be 17.8 meters tall. Okay, and then if we know that this height from your eyeball up to the top of pen high is 17.8 meters, well, we just need to add in this 1.4 meters that the person's eyeballs are above the ground. Okay, so our total height of this thing would be 17.8 plus the 1.4 meters, which gives us 19.2 meters. Okay, so there's an example of an application of trig. Okay, thanks very much, ladies and gentlemen, and we'll see you again soon.